Hello students, today we'll discuss IB Physics SL paper 1 May 2018 time zone 1. My name is Nariman Malim. I am located in Baku and here you can have my mobile and email. Which sources you can use to prepare for exam? Main huge textbook is written here. It is from Oxford 2014. Shorter textbook from Tim Kirk, also Oxford 2014. From examiners you should have number 1 IB Physics Guide 2016 with description of exam with syllabus, and this syllabus cites booklet formulas. What is this booklet? This booklet should be available for you during exam, and you should have a copy of this booklet, Physics Data Booklet, First Assessment 2016. Let's look to the cover page of the exam. It lasts for 45 minutes. It is 30 questions and 30 marks. Question 1. A student measures the radius r of a sphere with an absolute uncertainty delta r. What is the fractional uncertainty in the volume of the sphere? So this is the formula for the volume of the sphere. Analog formula is in the booklet. So if y equals a to the nth power, the fractional uncertainty equals n times fractional uncertainty, and when n equals 3, it is so much, and we can change y to v and delta a to r. So we get this formula which is b. Next question. A river flows north. A boat crosses the river so that it only moves in the direction east of its starting point. What is the direction in which the boat must be steered? Here we have to use addition of vectors. Straightforward, very accurate method is, let us consider resultant vector. Resultant vector is to the east, and it is the result of wind and result of boat. So if we need boat, we rearrange it for as this one, r east minus v wind or plus minus v wind. So we should add resultant motion to the east, and instead of subtracting, we will add negative wind. So negative wind is down, so negative wind plus east give us the direction of boat, so it is C. Another more easy method, so if we want to move to the east, we should overcome north, so we should go, one component should be to the south and another component should be to the east, so we get C. Question 3. An object is projected vertically upwards at time t equals 0. E resistance is negligible. The object passes the same point above its starting point position at times 2 seconds and 8 seconds. If g is 10 meters per second, what is the initial speed of the object? Here we should choose positive direction. So positive direction is up. I choose up, positive. Then initial velocity will be positive and our g acceleration will be negative minus 10. So formula for displacement after time t is given like this. Because at 2 and 8 seconds the object is at the same position, displacements are equal, so we write displacement at time t1 and t2 are equal, and we write expression for each of this time. G is minus 10, so minus 10 divided by 2 give us minus 5, so I substituted all values except u, and u appears to be 50, so answer is A. A uniform ladder resting in equilibrium on rough ground leans against a smooth rough ground and smooth wall. Rough means with friction, smooth means no friction. Which diagrams correctly shows the forces acting on the ladder? So let's look, for example, at A. The ladder is trying to slide down, so the lower part is about to slide to the left, so friction should be to the right, and here should be no friction. This is why we prefer B. So why not C? Because in C we have also this as if we have friction, and here as if we have friction, and here this is normal reaction at 90 degrees. In the middle we have weight acting because it is uniform, so answer is B. Question 5. An object falls from rest from a height h close to the surface of the moon. The moon has no atmosphere. When the object has fallen to the height h/4 above the first surface, what is the ratio of kinetic energy to gravitational potential at h? So here is the picture. So position 1, let me move it a bit. So position 1 is at the height. After falling 3/4, we appear at h/4. Don't confuse. It means that height changed by 3/4 of h. When object drops, kinetic energy change is positive and is equal to minus potential energy change minus mg delta h, or mg 3h/4. At 1, potential energy is mgh, so ratio is obviously 3/4, so answer A. Question is over. Question 4. Child X throws a ball to child Y. The system consists of the ball, the children, and the earth, so very big system. What is true for the system when the ball has been caught by Y? Looking to different answers, I found that in the end we have the total momentum of system has not changed. Yes, because there is no external force. This is conservation of law, so I like this answer. Although answer A is also attractive, but this is a conservation of law. It is very strong, so I choose D. Question 7. Increasing force acts on a metal wire, and the wire extends from initial length L0 to a new length L. The graph shows the variation of force with length of the wire. The energy required to extend the wire from L0 to L is E. So this is the graph that they give, and I have redrawn this graph here. What we know: energy stored after extension equals work done and equals area under the graph. So from L0 to L we have big triangle, and they say that energy here, or area, is E. Smallest triangle is one size. Height, for example, is 2 times less. So if size is 2 times less, then area is 4 times less, square. So it means that smaller triangle has area quarter of E. And we need area under the graph when it changes from L to half L, half extension, sorry. So we should subtract area of this triangle to get area of this trapezium. It is E minus quarter of E is 75 E, so it is answer C. The distance between successive positions of a moving car measured at equal time intervals are shown. Right. So the strongest statement here is constant acceleration. Let's check. So speed is distance by time. Let's take ourselves time to be 1 second. Then here we have 1 meter per second, 1.5, and so on. And what about the change from this interval to another interval 1 second passed, and the change is 0.5 meters per second. 0.5, and the change of speed is per second is acceleration. So we see that we have constant acceleration, so we choose answer D. Question 9. An object is moving in a straight line. The force F and resistive force F small act on the object along the straight line. Both forces act for time t. What is the rate of change of momentum with time of the object during time t? This is second version of second law of Sir Newton. Resultant force is equal to rate of change of momentum, and here resultant force equals F minus F. So rate of change of momentum will be B. A fixed mass of an ideal gas is trapped in a cylinder of constant volume and its temperature is varied. Which graph shows a variation of the pressure of the gas with temperature in degrees Celsius? According to ideal gas equation, PV equals nRT, so pressure is directly proportional to Kelvin temperature, but Kelvin temperature is expressed theta plus 273 for degrees Celsius. So we have here intercept. So we should have graph in the form y equals mx plus c. So this is graph A. It is not graph C because pressure is not directly proportional to Celsius temperature, and graph is not straight line passing through origin. Question 11. What are the units for the ratio specific heat capacity of copper divided by specific latent heat of vaporization of copper? So we write formulas for specific heat capacity. It is energy per mass per degree. For latent heat, it is energy per mass, and then we divide, and we get C, Kelvin minus 1. A sealed container of length L and cross-sectional area A contains n molecules of an ideal gas at Kelvin temperature. What is the force acting on the area of cylinder marked A due to the gas? Ideal gas equation, so PV equals number of moles RT. Number of moles is N over Na, N Avogadro, and R over Na equals K Boltzmann's constant. So now we have gas equation, pressure expression for pressure in terms of N. So force is pressure times area. Volume is for cylinder is area times length. So area simplified, and we are getting answer D. A first harmonic standing wave is formed on a vertical string of length 3 meters using a vibration generator. The boundary conditions for the string are that it is fixed at one boundary and free at the other boundary. The generator vibrates at frequency 300 Hz. What is the speed of the wave on the string? So frequency is 300 Hz. So this is a picture how it is vibrating. So fixed end is naught, open end is anti-naught. Distance between naught and naught is half lambda. Then between naught and anti-naught it is quarter of lambda. So naught is not moving, anti-naught is moving with maximum amplitude. So quarter of lambda equals the length of the string. So it is 3, it is 12. So to find speed we use wave equation. It is frequency by wavelength, so we get 3600 meters. We turn it into kilometers, we get answer D. Question 14. Two traveling waves are moving through a medium. The diagram shows for a point in the medium the variation with time of the displacement of the each d of the each wave of the waves. For instance, when time equals 2 milliseconds, what is the phase difference between the waves and what is the resultant displacement of the waves? So what we see that the waves have the same period, it is 5 milliseconds, there is only time shift. This time shift we will convert into phase difference. If period is 5 milliseconds, corresponds to 360 degrees, then shift of time 1.3, I read here 1.3 milliseconds, will be x degrees. So making proportion, we find that it is about 90 degrees. So time shift, phase difference is constant, but displacement is different. This is with time. This is why at 2 milliseconds we add +1 and minus 1.6 millimeters. We get minus 0.6 millimeters, which give us answer D. The diagram shows an interference pattern produced by two sources that oscillate on the surface of a liquid. As a result, we have interference pattern. Which of the distance shows on the diagram correspond to one fringe width of the interference pattern? So, still water and deep water. Still water is where the waves are meeting in phase. Out of phase, so we have destructive interference, and deep water when they are meeting in phase. So if we have this picture with bright and dark fringes, then which width is either distance between two successive maximums or between two successive minimums. Here C is distance between two successive minimums, so we choose answer C. A system that is subject to restoring force oscillates about an equilibrium position. For the motion to be simple harmonic, the restoring force must be proportional to. Here just recalling information. Acceleration should be proportional and opposite to displacement, and force is ma, so the same proportional to displacement. So we choose answer B, displacement from the equilibrium position. A particle is displaced from rest and released at time t equals 0. It performs simple harmonic motion. Which graph shows the variation with time of the kinetic energy of the particle? First of all, kinetic energy is always positive. Formula for kinetic energy is mv squared, and if it starts from rest, then at the beginning the kinetic energy should be 0. So only positive is C and D, from rest is D, so we choose D. Three resistors are connected as shown. What is the value of the total resistance between X and Y? So let's see. So 3 ohm and 3 ohm are connected in series, so they can be replaced with 6 ohm resistor. Then we have 6 ohm resistor and 2 ohm resistors connected in parallel, so we either use formula for parallel connection, or there is simpler formula for two resistors, product divided by sum, so we get 1.5. A liquid that contains negative charge carriers is flowing through a square pipe with sides A, B, C, D. A magnetic field acts in the direction shown across the pipe. On which side of the pipe does negative charge accumulate? Here we should recall Fleming's length-half rule. So we put left hand in such a way that first finger is pointing to the field, second finger to the conventional current, and thumb shows the thrust. Conventional current is opposite to moving negative charge, and the same for moving positive charge. So I have tried to draw, so conventional current will be in opposite direction, field is to the left, conventional current is, let's say, from us, the thumb of the left hand shows up, so the push will be up, and negative charge current are pushed here. Answer A. Question 20. 5 resistors of equal resistance are connected to a cell as shown. What is correct about the power dissipated in the resistors? I decided to use, because they have the same resistance, I decided to use formula voltage squared over resistance for power. There are several formulas, and everything will depend on voltage. So let's take resistance to be 2 ohms. Then 2 ohm and 2 ohm in parallel give us 1 ohm, and here we have 2 ohm and 2 ohm 4, and 2 reverse give us inverse. We use formulas for inverse. 4 over 3, so here we have total resistance more than 1 ohm. Here 1, here more than 1. So actually we have potential divider, and the right part gets more voltage than the left part. It means that voltage on Z will be greater than on X, and voltage on Z will be greater than on Y. So it means that if power is voltage squared over resistance, the greatest voltage will be and power will be on Z. So answer C. Two resistors X and Y are made of uniform cylinders of the same materials. X and Y are connected in series. X and Y are equal length, and the diameter of Y is twice the diameter. So the resistor of Y is R. What is the resistance of the series combination? Right, so resistance of Y is R. Resistance of Y can be written in this way. Resistivity, I called it K here. Okay, actually it's wrong. Length over area. Area is with D, diameter, pi d squared over 4. The same formula I have for resistance of X, but I changed D to D over 2 because diameter of D is 2 times greater. Then I use my method, which I called ratio method. I find the ratio of Rx to Ry. When I divide, I get 4. Then I rearrange this ratio for Rx. I get Rx equals 4R. So this is 4R, this is R in series, so total will be 5R, answer D. Question 22. An object of mass m at the end of the string of length r moves in a vertical circle at a constant angular speed omega. What is the tension of the string when the object at the bottom of the circle? At the bottom of the circle, we have tension acting to the center and mg acting away. Because it is moving in the center, centripetal force is towards the center, so tension is greater than mg, and the resultant force gives us centripetal force. Resultant force will be T minus mg, so resultant force equals T minus mg. Resultant force is at the same time centripetal force. If you look in the booklet, you can conclude that acceleration equals omega squared r times r, and force is m times acceleration. So we substitute expression for centripetal force, then rearrange for t, and we get answer A. Newton's law of gravitation. By method of elimination, the best answer is C, because it is not equivalent to the second Newton's law. It doesn't explain the origin of gravitation, and it is valid in vacuum. So answer C is left. 24. Which Feynman diagram shows beta plus decay? This you should remember. Upper quark decays into d quark with positron and neutrino. So lepton law is conserved because positron has as antiparticle has -1 lepton, and neutrino has 1. But actually you should remember the formula and understand the Feynman diagram. So it is time is vertical and position is horizontal. So first we have u particle, then we have up quark, then we have positive down quark and positive W bosons, then we have in opposite direction for time antiparticle in opposite direction, and neutrino in positive direction of time. The average binding energy per nucleon for nucleus of oxygen is so much. What is the total energy required to separate the nucleus of one nucleus? Okay, first of all, protons and neutrons, nucleons are 15, so 15. Average is total by number. Total is average by number, so 7.5 for each multiplied by 15 give us answer C, 26. The two pure samples of radioactive nuclides X and Y have the same initial number of atoms. The half-life of X is T. After 4 half-lives of X, the ratio is 1/8. What is the half-life of the Y? Let's call unknown X. After 4T, half-lives of Y is 4T/X. So number of undecayed X will be it's better than I call it X. Okay, so we have already X, so let's call it small x. Small x for okay. So after 4T, half-lives of Y is 4T/X, and then so undecayed X atoms is n divided by 2 raised to the number of half-lives divided by number of undecayed Y is n divided by 2 raised to half-lives of Y, and here 1/8. So we have here our actual equation for powers of 2. So we can equal exponents, or we can take a logarithm with base 2, and we get this expression. Let's make again this small x, and small x will appear to be equal to 4T. So it is answer D, 4 times greater, period. The energy level diagram of an atom, question 26, has 4 energy states as shown. What is the number of different wavelengths in the emission spectrum of the atom? So the more energetic levels are called excited. An atom is trying to decrease energy when it goes from higher energy to lower energy level and emits light. So it is called emission spectrum. So let's start from the highest position. From highest position we can go 1, 2, 3 transitions. From next 1, 2. From another 1. So finished 6. So answer is C. 28. What is equivalent to specific energy of fuel over energy density of fuel? Specific energy of fuel, energy per kilogram, energy density, energy per volume. We divide and we get mass, 1 mass over volume, which is 1 over density. So answer B. 29. 3 energy sources for power stations are fossil fuel power, pump, water storage, nuclear. What energy resource are primary sources? So pumped means we use another energy to pump this water, so 2 is not working. Fossil fuel is a primary, and nuclear fuel is primary. So it's not made by us, it is made by nature many millions of years ago, so we choose answer B. Last question, 30. The diagram shows a simple climate model for Earth. So we have income and reflected energy. What does this model predict for the average albedo of the Earth? So albedo is total scattered by total incident. But don't pay attention to other information, observed, etc. Only scattered by incidence. Scattered is 6, 24. It is 30, and incident is 100, so we get answer A. This finish my discussion of this paper. I can say that about 60% of questions are from HL level, only 40% are new questions. See you next time.